Convert 634 millimeter mercury to ATM, torr or kilopascal. I will say this is a very common unit. Eh, How to convert a millimeter mercury to ATM? 1 ATM equals to how many millimeter mercury? You need to remember this is a very common conversion factor. 760. Okay, 760 millimeter mercury. So millimeter mercury concern, right? Leftover ATM. This is what you want. Use a calculator. You easily get the answer. Right, this is 0.834 ATM. I will not ask you this. This is not very common. But it is another unit for pressure. So 4 millimeter mercury is the same. 1 millimeter mercury equals to 12. Then this is the same. 634. 634 millimeter mercury is the same as torr. Because 1 torr is a 1 millimeter mercury. Then how about kilopascal? Kilopascal in the upper level class, it's common unit for pressure, but in Chem, not very common. So kilopascal, you need this ATM first. So we still need to go through ATM first. Then 1 ATM is 1.013 times 10 to the fifth power Pascal, then 10 to the second power kilopascal. So 1 kilopascal is 1,000 Pascal, right? So 1 ATM. This equal to 84.5 kilopascal. Okay. For you guys, millimeter mercury to ATM, you must understand. Okay, this is the most common pressure unit. Okay, IRK. And next, 32. Given that 6.9 moles of carbon monoxide gas are present in a container of volume 30.4 liter. Here you moles 6.9, volume 30.4 liter. What is the pressure of the gas if temperature is 62 degrees Celsius? So tell moles, volume, and temperature as you calculate pressure. Okay. 32. Tell us moles, 6.9 volume 30.4. Temperature 62 degrees Celsius. Ask you pressure. Can we calculate the pressure? Yes. Ideal gas equation. I always think about ideal gas equation. PV equals to nRT. Then P equals to what? Both sides divided by V, right? So nRT divided by V. I wish ever this time everybody can solve this. nRT divided by V, not V divided by nRT. And so N 6.9 more. R I will provide you during the quiz or test. So the gas constant 0.08206 liter ATM per mole per K times T. Can we use 62 directly? No, because this R is per mole per K. This is Kelvin. So we need to convert the Celsius to Kelvin. Celsius plus 273.15. If you don't remember 0.15, you use 273, that's fine. But you cannot use Celsius degree directly. Must be converted to Kelvin. V 30.4 liter. Right. Then you find mole cancel this per mole. Kelvin cancel this per this Kelvin cancel this per Kelvin. And the liter cancel this liter. Left over ATM. This is the unit you want for pressure, right? So now just use your calculator. 6.9 times 0.08206 times this is 335.15. Then divided by 30.4. Use calculator, you can easily get into this 6.24 ATM. Are you okay for this? This is pretty straightforward. You need to remember this ideal gas equation. 32. What is next? 43. A volume of 0.28 liter of gas at STP. This is 43. Volume 0.280 liter of a gas at STP. What does this mean? This means temperature is 0 degrees Celsius. Pressure is 1 atm. This is standard temperature and the pressure. So this actually tells you the temperature 0 degrees Celsius. Pressure 1 atm. Temperature, pressure, both are non-value. The volume of 0.28 liter of gas at STP weighs 0.4 gram. The mass is 0.4 gram. As you calculate molar mass. So we need to use equation related to molar mass. One is density, one is molar mass. These two actually from same equation, right? So do you remember density is PM over RT, right? If you remember this, then this M is molar mass. Here we use MW because in chapter 3 we use M as the molar concentration, right? So MW is molar mass. Then from here we can rewrite, so molar mass should be D times RT divided by P, right? So I would suggest you remember one of these. Don't try to remember both. Try to remember both, you may confuse. Okay. Remember one, you can easily get the other one. Okay. Since here asks you molar mass, so if you only remember this, then just rearrange it, become this. Now, do we have the? Then tell us the, but tell us mass, volume, mass divided by volume give you D, right? So mass divided by volume give us density. So mass, volume, both are non-value. R is a gas constant. So number is here. I will provide you during the test. T temperature, 0 degrees Celsius, convert to Kelvin, is a non-value. And P, 1 atm. So every parameter is a non-value. Right, so we can calculate. Now just plug into number. And mass is 0.4 gram. Volume 0.28 liter. Gas constant 0.08206 liter atm per mole per K. Temperature 0 plus 273, right? More accurately, it's 273.15. And pressure 1 atm. Now you find atm cancelled, and liter cancel this per liter, K cancel this per K, and left over gram per mole, which is the unit we want. Molar mass is gram per mole. So if your unit is you want, then your formula most of the